Okay, we will find out power series expansion for the function natural log of 1 plus x. And of course, we will utilize our best friend. So of course, I will write it down right here for you guys. And here we go. This right here is of course 1 over 1 minus x. And this is the sum as n goes from 0 to infinity, x to the nth power. And don't forget to mention the absolute value of x has to be less than 1 in order for the best friend to actually work. Now, what's the connection between this and that? Well, we notice that the best friend is just 1 over a linear function. If we integrate that, we get ln of something, right? So that will be a good approach. We will just focus on how to integrate this. However, the input here is 1 plus x, but the best friend is 1 minus x. So we have to do some change, and here we go. Let's go ahead and write 1 over 1 plus x as follows. The 1 stays on top, doesn't matter, and this right here is just 1. But for the plus x, I would like to look at this as negative x, like that, right? And then, of course, now we can just put this right here for this, which is the sum as n goes from 0 to infinity, and we have negative x to the nth power like this. And technically, of course, I will still have to put down the absolute value of negative x is less than 1. And this is still absolute value of x is less than 1. All right, now, perhaps I'll write this down again. This is 1 over 1 plus x. And then on the right-hand side, let me just put this down. We have the series as n goes from 0 to infinity. This is like saying negative 1 times x. So we can look at this as negative 1 to the nth power, like this. And then we have x to the nth power, like so. Then what do we do? Well, it's about time for us to integrate. So integrate here, likewise integrate here, and don't forget we integrate this with respect to x in the x world. On the left-hand side, when we integrate 1 over a linear function, we get natural log of the input, which is 1 plus x. And notice, we don't need to put down the absolute value because, well, we said it, the absolute value of x is less than 1. So when x is in between of negative 1 and 1, this is always going to be positive. Therefore, we just need a parentheses. And don't forget to check the derivative of 1 plus x is what? It's just 1. Divided by 1, doesn't matter. So that's it. And the plus c shall be just going to the right-hand side. So when you integrate this, go ahead and put on c plus, and then you have, well, to integrate this guy. Very easy. We love to integrate power series because you just focus on the power, you add 1, and that's your new power, and you divide it by the new power right here. That's pretty much it. So you see that this is the series as n goes from 0 to infinity, and you write down the coefficient, which is negative 1 to the nth power over n plus 1, and then multiply by x to the n plus 1 power, like that, right? Then you also have to figure out the c, and to do that, we just have to plug in an x value to help us out. A good x value is 0. Why? Because 0 is first of all on this interval, and when you put 0 right here, we get ln of 1 plus 0, which is just ln 1, which is just going to be 0. And this is c plus the series as n goes from 0 to infinity, negative 1 to the n over n plus 1. And you put 0 in here, so we have 0 to the n plus 1 power. The left-hand side is 0. That's equal to c plus. Now check this out. When x is exactly 0, you put it here. When n is 0, the first term is 0 to the 0 plus 1, so 0 to the first power times whatever, and 0. And in fact, this right here is just always going to be 0 plus, and all that, right? And x is exactly 0, so all in all, this right here is just a 0. And of course, c has to be 0. That means right here, c is equal to 0. Don't ever just skip this step. Sometimes c is not 0, okay? When you integrate this. An example is when you integrate sine to get negative cosine. Yeah, when you do it with power series, c is not 0 in that case. But anyway, that will be for later on. So I will just tell you guys that this is the answer that we have. ln of 1 plus x. This is equal to this right here, which we have the sum as n goes from 0 to infinity. And we have negative 1 to the nth power over n plus 1. And then x to the n plus 1 power, like that. Well, we know that the radius of convergence is 1. Because when you integrate or differentiate the best friend, the radius of convergence wouldn't change. And even though this is the best friend's cousin, but it was still 1 anyway. So this was still equal to 1. However, for the interval of convergence, this right here, we know it's going from negative 1 to 1. But we didn't know if it converges at exactly negative 1 or if it converges at exactly positive 1. We didn't know. So we will just have to do a quick check. So here we go. So go ahead and check. Check the convergence at the endpoint. First, let's do negative 1. This is bad because if you look at this function, if you put negative 1 here, ln of 0 it's not defined, so it does not work. That's just a quick way to do it because we happen to have natural log of x. Oh, natural log of 1 plus x. So it wouldn't converge. However, though, that's not always the case all the time. So just ignore this for now. To do the check, if you put negative 1 here, you are looking at the series as n goes from 0 to infinity, negative 1 over n plus 1, and you put negative 1 in here, n plus 1's power, and I know I haven't put down n's power right here. Anyway, this is the time that we have to use the convergence test that we have done in the past. And let's just do this quickly, okay? Notice here we have negative 1 to the n plus 1's power. This means negative 1 to the n times negative 1 to the first. Yeah? And the good thing is that negative 1 to the n times negative 1 to the n, this is always positive. So you have the following. This is equal to the sum as n goes from 0 to infinity. This is just a positive 1. Positive 1. Again, n plus n is 2n. Negative 1 to the 2n is always 1. However, we do have a negative 1 to the first power, which is negative 1. You just put that all the way in the front, like this. And then we have 1 and over, this is n plus 1. Yeah? So it's like that. And the truth is, this right here is equal to, can we still see? Maybe, maybe not. This right here is negative. If you put 0, you get 1. If you put 1, you get 1/2. And if you put, what's the next one? And so on, you get 1/3. And so on, so on, so on. The truth is, this right here diverges because this is the harmonic series. Harmonic series. Yeah. Anyway, you could have done that, but you should do the check for this case though. Because again, this is how you check the endpoints of the power series for the convergence. Then you check when x is equal to 1. Oh, by the way, this diverges when x is negative 1, so you put parentheses. Then we check when x is equal to positive 1. You put positive 1 in here. So we are looking at the series as n goes from 0 to infinity, and then you just have that only, negative 1 to the n over n plus 1. Technically, you put 1 right here, and then n plus 1's power. Well, this is always 1, so you look at this. Therefore, you are looking at the sum as n goes from 0 to infinity, and you have negative 1 to the n's power times 1 over n plus 1. And in fact, this will give you the alternating version of the harmonic series. Right? So this right here is actually going to be, let's see, you put 0 in here, you get 1, and then you put 1, you get negative 1/2, and then plus 1/3, and minus 1 over 4, and so on, so on, so on. Right? Yeah, so hopefully you guys can see that. Now just step out a little bit. And this right here converges. And you can use the AST if you would like. You can use the AST right here. Right? And when x is equal to 1, well, you can come here and give that a bracket. So we are done. I know after a while. But this is it. This is it. In fact, when x is equal to 1, this series right here, which is the alternate version of the series. Let me just take a guess at the b right here. This series right here, right? It converges to ln of 2 because right here you can just say this is equal to, let me just say this is equal to ln of 1 plus this 1. So this is equal to ln of 2. Yeah? So that's this right here. Yeah, so that's how you calculate the value for the alternating harmonic series, and it converges to ln of 2, which is really cool. But anyway, that's it.